Hello webs, hi, this is Fahad from Future Phones, and today I have a Lenovo Yoga 260 ThinkPad laptop, and this laptop came in as a dead laptop. It's not powering on, and I have removed the screws of the back cover, and I can see that there is some heat marks on the SSD drive here, and we have some heat mark on this coil also. We just take you there so you can see. So we have heat marks on this coil here, and this SSD card, there is some heat marks here as well. And when we put when we connect the charger to this laptop, we have a light, but it's not powering on. When we press the power button, it's not taking no load on my power supply. So we'll just give it a try one more time. So this is connected, and I'm going to take you to here, and you can see I'm pressing the power button, which is here, and you can see it's not taking no load, so it's not powering on at all. Okay, let's so we got one clue that something has been worked on in this area. So it has previously been worked on, and you can see there is these heat marks, and they have burned this sticker as well. So we will take this the battery off. First thing we will do, take the battery off, and we will remove these connectors, get the board out. And so next thing I'm going to do is remove these LCD and the LCD touch connectors. Okay, so the board is out of the casing. So this laptop has been worked on before. You can see that the stickers are a bit, they've been taken off, so they are not in the factory condition anymore. I'm going to remove them as well. Okay. To remove this sticker, we need to get the heatsink off. I'll put this back on. This will just stick to my hands. I don't like that. Okay, the fan connector is on now, so we'll take this off. Okay, so the board number is LA-C582P. This is the board number, and unfortunately there is no schematics for this model C582P, but we have schematics available for C581P, which is a similar board. The difference is with this RAM slot. So the C581P has a detachable RAM slot here, but in this one you can see that it's been built in on the board. Otherwise they're more like they are same boards, because I can tell you this because I have a couple of boards for spare and parts. I purchased those boards, and if you have the board, you can repair the laptop very quickly. So everyone should have the spare boards. Okay, let's go into the microscope. So my microscope is on now, and let's examine the board from the charging jack, and we will see if we can find any visible or physical damage. You can see here this screen connector is a bit, there is some soldering sign here, but that's I don't think there is nothing to worry about on this one. So this is a fuse, and after this we have a combination of MOSFETs here. So there is like 4 MOSFET, and this is the power SRC or the current sensing resistor here, and after that this power is distributed to the board. So this area, it has some solder here. This is some junk here, I don't know what that is. So this is our clock. This is the built-in RAM. Any other thing that we can find out? Any physical damage that we are looking for? Anything that is out of shape? We'll start checking that. Okay, so this is the area I was talking about, that there is some heat marks on this paper here, and there is, you can see that this MOSFET has been changed. This MOSFET has been changed, but and I think this heat mark is because of this MOSFET also. You can see here some soldering balls here, so some work has been done here. We'll check this part. Anything else on the board? That looks neat, clean. So we have PL4, PL3, and then we have PL5. Okay, let's check this side of the board. This looks clean. So that looks okay. I can see some flux here also. It's just a little bit of it. You see this diode is, or this is a transistor actually. Yeah, it's out of shape, but it's holding its pin, so nothing to worry about. So the rest of the board looks fine. It's nothing really something that's catching my eyes. No. What is all that? So this is, I think this is from the factory. Some flux. So that is fine. So let's check this coil. So my multimeter is in the beep range right now. Let me just go in the beep range. We will check all these coils. So we'll start from PL3. So this is there is no resistance, that's fine. So that's fine also. So you can see this is short to ground, this coil is short to ground, PL5 is short to ground, and I think PL5 is receiving its voltages from this MOSFET. And okay, see, this MOSFET is also showing shortage. I don't know. Okay, all this area is showing short, so all this area is showing short. That's fine, we can have a look at it later on. Okay, let's check the current sensing resistor. What is it showing? Oh, this current sensing resistor is showing short to ground as well. So this side of the MOSFET is connected to current sensing resistor, as you can see here, and that's why it's showing short to ground. This is also showing short to ground here, but this is a separate area, so it's not showing short to ground. That's fine. So that's okay. So because now we have found two areas where we have found shortage. This area is already, you know, that is discolored, so this is our main suspect. We can remove this coil and we can figure out where the shortage is, and after that we can remove those parts wherever there is a shortage. So I can start by removing this coil, or I can start by removing this MOSFET here. So let's do with the coil first, and I will also remove the current sensing resistor. So let me just remove the current sensing resistor before. This is the current sensing resistor here. When we remove the current sensing resistor, we are separating the areas where there is a short. So this is like a bridge kind of thing. So this is a ground check. So we don't have short in this area now, but we have short. So you can consider this is the input area of current sensing resistor, and this is the output area, and this output area is giving voltage to the rest of the board. So we have a problem in the rest of the board. Let's check these MOSFETs, because this can be sometime tricky as well. It's best to check the MOSFETs as well. So you see, this MOSFET is fine. This should be OL. Oh, this is the what this is the value. That's fine, that's fine. So this should be OL. That's okay. Okay, so you can see here we have a shortage on this MOSFET as well. So we have two problems. One problem is here, this MOSFET is showing short as well, and we have a short on the output of the current sensing resistor. Okay, I'll deal with this MOSFET first. because I'm working in this area right now. So I'll remove this MOSFET. Okay, we can check this MOSFET. So we go in the diode mode range, and we can check. There should be some value if this is fine. So you see, this has become a wire. So the MOSFET is not supposed to behave in this manner. The MOSFET it passes the voltage from source to drain, but this is controlled by this gate. So the gate allows the current, or whatever current is required by the board. So in this case it has become just kind of a wire, and a wire is not what the board requires. And your board, due to this gate, the board knows that something wrong has happened here, and this could be one reason, because you can see this voltage from the adapter went to this fuse, and then it went to this MOSFET, and from here your current was, because it was short, so without gate pass it was going into the board. That may be the reason why we have a short in the other area as well. So we can deal with that. So that's fine. Let's see here, we still have a short on the output of the current sensing resistor. So this MOSFET is definitely faulty. This is okay. This is okay. Okay, so this is faulty. I will just move it out of the way. This current sensing resistor, we can check it. This is fine. So we'll use it. Now let's come to this coil, because this coil was also showing short, which is PL5. Why I'm so certain about this coil being short, because you can see the value is all the way 000. So the voltage drop between black to red is almost 0 here, so that's why we are getting 0. And you can check, I'm connecting this to my ground here, so voltage drop is almost 0. And this is the same situation here on this coil. So something is not right. Somewhere down the line this coil, it is possible that the output or the input of this coil is short. So we can find out once we remove this coil. Just remove the coil, come on. Now let's find out where the shortage is. So this is the input area. Okay, we have shortage on the input area. Output area is clear, you can see. So this MOSFET is supplying switching power to this coil, and this coil is transferring that switching power, or AC, kind of AC power. This is actually DC power, but in the switching form, so which is like in on and off situation, which is like in the waveform, and this coil is transferring that wave into the DC current, pure DC current, which is like a straight line. So this area is okay, output area is fine. In the input area we have 0 0, and this input area is connected to this MOSFET, so we will remove this MOSFET now. So no wonder this area has been worked on before, because you can see there is some heat marks on this sticker here on the top. But the problem is, I'm quite sure that because that MOSFET was faulty over there, the first MOSFET after the fuse, and that MOSFET was allowing the current without the gate pass, and that was causing the issue. Okay, let's check this MOSFET. It's a dual MOSFET, and you can see this should not be beeping. It should give us some value here. Okay, and now so this MOSFET is beeping. So consider this as this is the drain, and this is source, and this is drain, and this is source. So we are testing two MOSFETs in this condition, and in both conditions it is showing just like a wire. You can see it's a 0 0 0, so there is no resistance. The diode inside this MOSFET has burnt, or is just shorted, so it has become like a wire. That's why we are getting 0 0 0. Okay, let's check, do we still have the short? So we don't have a short here on this pin because we have removed the faulty component. It's not there. Well, let's check here. We don't have a short here. We don't have a short here. Okay, this is the ground area, so it is supposed to beep. That's not problem. This is the gate of this MOSFET, so it's open line. That's fine, and we have some value here, but there's nothing to worry about that. So we have two problems, two faulty components that we have figured out so far. So this MOSFET is faulty also, so I'll keep it aside, and I will go back to my current sensing resistor, which was here. Since I have removed the shortage from that MOSFET which was connected to PL5, yep, now we should not have a short on the current sensing resistor also. Let's check if we have solved it. So you can see now current sensing resistor has no more short. Okay, I think if we change these components, we have a working board. Okay, so put this current sensing resistor back on. Okay, this is my board for the parts. I will extract the do I need this MOSFET. Okay, let's get this MOSFET out. Okay, so we'll put this MOSFET to our faulty board. So let's see, orientation is fine. Let's check in the diode range. So it's an open line, should have some value on the other side. Perfect. So this area is clear now. We have found out there was a faulty MOSFET, so we changed it. Current sensing resistor back in on its place. Now if we come back to this area, we have a coil to put on. There's the coil. Okay, and a MOSFET. So we'll take this MOSFET from this donor board again. It's a good MOSFET. Okay, let's take this MOSFET out. We will compare this MOSFET with the faulty one, so we will have some understanding how these MOSFETs work. So this is our faulty one. The faulty one is here. This is the one we have just taken from the donor board. So my multimeter is in the diode range, you can see. So this one is faulty and this is from the donor board. So this one was showing as a wire, you can see 0 0, and this area was showing 0 0 as well. So let's check this one. So you see we have value. So that's how you can check a dual MOSFET. Okay, see we have some value. So is this MOSFET has a diode inside. In this particular MOSFET we have two diodes, so that's why it's called dual diode MOSFET as well. So we are checking the value of that diode with these probes. So voltage drop is of a diode is almost like between less than 0.500 milliamps. So 0.500, I don't know if it's count in the milliamp, but it's 0.500, less than 500. So any value, that's fine. Less than 500 or less than 600, that is fine. But in this one you can see it's a faulty one, so it's acting like a wire. So there is no voltage drop between these points. So we'll throw it in the bin, this one. So we have a working MOSFET that we have tested. We will put this MOSFET in here. Use some plugs. Okay, let's give it a test now. And you see, before it was short to ground, now it is showing a value. It is showing some resistance, so I'm quite sure this is okay. Okay, let me check which sort of MOSFET is this now, because these MOSFETs, when they go faulty, wherever they are getting power from, that IC goes faulty as well. So I'll show you in the schematics. Let's check. I mean, we can give it a try and we can see if it is working now, but if we have the similar if we have a problem, then this MOSFET will go dead again, because the power which is coming to this MOSFET, if that power is shorted, then it will short this MOSFET again. So it will keep repeating. It's a vicious circle, and IC could be faulty as well. Just to be on the safe side, I'd change the IC as well, which is connected to this MOSFET, because I don't want to give power to this board and find that I have this MOSFET faulty again. So just to be on the safe side, I will check where this MOSFET is getting power from. So we will open our schematics. Just give me a second. I'm just trying to open the schematics for this board, and C581P. I just saw it here. Oh shit, I just saw it. Okay, let's take you to my desktop, and this is what the desktop is about. So we have opened the C581P, and we are looking for PL5. Sorry, my keyboard is not working. Okay, let's look for the PL5 in this schematics. Okay, this is where our PL5 is, and PL5 is connected to PQ196. You can see here, this is PL5 and is connected to PQ196, and yes, the MOSFET that we just replaced, the dual MOSFET, is a PQ196, and this is connected to PU1. So PU1 is the IC that's controlling this MOSFET. So this MOSFET goes faulty, and there are chances that this IC has gone faulty as well, along with the MOSFET. So you could always take a risk, put this MOSFET, give power, and this IC, if it is faulty, then this MOSFET will go bad again. So I would rather, because I have this IC available in the donor board, so I will extract from there and put it into this board. So I know for a fact that both my parts have been changed, and there should not be any more problems. Okay, let's go back to the microscope. The one we are looking for is PU1, and microscope. So PU1 is it should be somewhere close by to this. Yeah, it's right behind it. You can see this is PU1. Sorry. So this is PU1. I will change this IC as well. So let's let's change the PU1 and give some flux. Not too much, not too less. So this IC is BQ247805, I think. So I will take this IC off. I mean, this IC could possibly be good IC, but I don't want to take a risk, because then the Mosfet will be dead again, and then I will have to diagnose again. In most cases the IC goes faulty as well, so we change the IC as well. Or sometimes the IC works for some time and then it causes the issue, the same problem, it causes the same problem. So this is our donor board. PU1 is here also, so I'll just get the PU1 out. Okay, this is our donor IC from the donor board. Let's retin this legs from this. Let's retin these pads, because there is very little flux solder left now. Okay. Yep. My soldering iron is still cold. It's not ready. It's okay. I will use the momentum. So that's okay. Now I'll just remove some of this. It's too much in here. So my BQ247805 is here now. So pin number, this dot will go to this point. You can see the dot is facing this orientation mark. Let's put this IC on now. So don't worry too much about this. Okay. So I'm just pressing this IC now and giving some hot air. Now the excess solder is on the legs or the pads. I'll just remove them. Okay. give it a clean. Okay. Okay, that looks clean now. Okay. Okay, now let's give it power to the board. Give the power to the board and let's see what happens. Okay, we have a fan spin. That's good sign. So very good sign actually. And our ampere, if you see here, is rising to 472, 361, 507. Now is going down to 214, and at this point, if it rises again, then we will have a display, because that was a reset cycle. Now I will check it in the display if we have a display on the screen. Okay, let's check it. Okay, do we have a display? If we have a display, then our job is done. We have revived the board. Just give us some time. So oh yes, look, we have powered it on. We have display on, and you can see this is fixed. So this board is fixed. Now we will okay, we will assemble it and diagnose further if there is any other issues that needs to be looked at. Our main job is done. We have powered it on, and we will see. I have a phone call as well at the same time. So this is fixed. This is how you